So our next step is going to be to look at something that's a little busier, a little more complicated. I want to see if I can find a formula for the cosine of the difference of two angles. For example, I have something like cosine of A minus B, and I want to know what does that equal. Well, you'd kind of like for this to behave like a linear function does and have this to be cosine of A minus cosine of B, but unfortunately that doesn't work. And you can see this pretty quickly. It's easy to come up with counterexamples. For example, if I let A equal 0 radians and B equal pi radians, then the left sign is cosine 0 minus pi, which is the cosine of minus pi, and that's minus 1. But if we do the right side, this is cosine of 0 minus cosine of pi. Cosine of 0 is 1, minus cosine of minus pi is minus 1, and that's 2. Yeah, doesn't work, right? You can't do that. Okay, that doesn't get me off the hook, though. I still want a formula, right? So that's what we're going to do, right? We're going to derive a formula for the cosine of the difference of two angles, right? And here's how it's going to work, right? I'm going to start with this diagram, and I've got these two angles, and let me clarify what these angles are, all right? This angle here is B, so angle B is angle ROT, right? It's that smaller angle there. And angle A is the whole thing here. So angle A is angle ROS. Okay, and the angle that I'm interested in, right? Because remember our goal. We want to talk about angle A minus B and what is its cosine. So the angle that I'm kind of interested in here is this one, right? That angle is A minus B. All right, and here's what I'm going to do. I'm going to redraw this. Okay, I'm going to redraw this. And what I'm going to do is I'm going to redraw it with that angle, A minus B, kind of repositioned so it's in the standard position. So its initial side is on the positive x-axis, and its terminal side is up here. Right? So those angles, they're the same, right? A minus B, just in two different places. Okay, so now what I'm going to do is I'm going to clean this up, right? I'm going to redo the left-hand drawing. And what I'm going to do is I'm going to take the positive x-axis, the positive y-axis out, just to make the drawing look a little less cluttered, right? So it's going to look like this. Now let me clear out my sketching here, right? And I've added a few facts, right? Remember, this was angle B, which means the coordinates of this point, this is a unit circle, I should have mentioned, right? This is our traditional unit circle, so the radius is 1, and that means the coordinates of this point are cosine B comma sine B. Okay. And the same thing with the other angle, right? This large angle here is angle A, which means the coordinates of this point are cosine A comma sine A. And what I did is I kind of filled in the triangle, right? I created a triangle here by connecting those 2 points. All right, now I'm going to do the same thing over here on the right-hand diagram. I'm going to take out the positive y-axis just to clean up the drawing a little bit, right? And I drew in that line again, right? I drew in that same segment here. And because this angle is A minus B, again, in a unit circle, the coordinates of this point must be cosine A minus B, sine of A minus B, and that's nice, right? Because you see the cosine of A minus B just came into the question, just came into the diagram, and that's what I'm trying to find. Okay, so let me Let me point out a couple things. We've got two triangles here, right? I have triangle, whoops, not A. I've got triangle OTA over here. And over on the other side, I have triangle ORU. And I want you to notice a couple things about these triangles. Okay, first, this side OR is congruent to side OT. They're both radii of the circle. They're both 1. Similarly, the other sides of the triangle here, these two sides, they're also congruent. Because again, they're both radii, their length is 1. And finally, this middle angle here is A minus B in both triangles. So look at what I've got now. I've got a pair of sides, I've got two pairs of congruent sides, and the angle between them is congruent. That means, I'm flashing back to your high school geometry here. That means from the side angle side congruence theorem, these two triangles are congruent, right? And this is the key part. Those two green lines, those two dashed lines that I added, those lines are congruent, right? So segment ST is congruent to segment UR, which means their lengths are the same. Okay, and I can find their lengths. I can come up with formulas for those lengths using the distance formula. So look at ST over here. The distance formula says that length is the difference of the x coordinates, that's cosine A minus cosine B squared, plus the difference of the y coordinates, that's sine A minus sine B squared, and it's the square root of that whole thing. Okay, now I'm going to do the same thing on the right side. Right, and first notice this point down here, right, that vertex of the triangle, it's on the circle and it's on the x-axis. So the coordinates of that point are 1, 0. All right, so now I can use my formula again. The distance here is cosine A minus B minus 1 squared, plus that's the difference of the x-coordinates. Now I'll do the difference of the y-coordinates, sine A minus B minus 0 squared, and take the square root of that whole thing. Okay, from here, I want to say it's all downhill, but it's a very muddy, rocky hill. Okay, all I'm going to do is I'm going to solve this equation for cosine A minus B. It's not hard, it's just some, the algebra is going to get a little bit messy as we go along, and before it cleans up and we get a nice formula in the end. And unfortunately, I have nowhere near enough room to do it on this slide. Okay, doesn't happen very often that I run out of room, but this is going to be one of those times. So what I've done, I'm going to go to the next slide here. And what I've done is, right, this was my equation. The two side lengths are the same. This is the equation, that was the last thing I wrote on the previous slides, the distance formula equation. And I cheated a little bit on the next step. Our next step is just going to be to square both sides. That's going to get rid of the square roots. And I'm going to be left with this. Okay, so from here, here's where it starts to get messy before it gets clean. So what I'm going to do is I've got all these things being squared. I'm going to multiply them out. All right, so this first piece here becomes cosine squared A minus B minus 2 cosine A minus B plus 1. All right, then I'm going to do this part. Well, that part's already done, right? There's nothing there to multiply out. That was the part that was minus 0, right? So that part is going to stay just sine squared A minus B. Okay, equals. Now let's do the other side. I'm going to multiply this piece out. That's cosine squared A minus 2 cosine A cosine B plus cosine squared B. All right, and finally, last but not least, let's do this piece. That is plus sine squared A minus 2 sine A sine B plus sine squared B. Okay, now it's going to clean up pretty quickly at this point. Notice a couple of things. I have cosine squared A minus B plus sine squared A minus B. That's 1, right? That's our first Pythagorean identity. So this side becomes 1 minus 2 cosine A minus B plus 1. All right, and I'm going to do very similar things on the left side here, on the right side. I've got cosine squared A plus plus sine squared A. That's equal to 1. And I've got cosine squared B plus sine squared B. That's equal to 1. And what's left? Minus 2 cosine A cosine B minus 2 sine A sine B. All right, we're almost there. Actually, it's going pretty quickly. Here I have, on the left-hand side, I've got 1 plus 1. That's 2, right? So let me write it. I don't want to skip too many steps. This is 2 minus 2 cosine A minus B equals, and I'm going to combine these two 1's together, 2 minus 2 cosine A cosine B minus 2 sine A sine B. Subtract 2 from both sides. Right, eliminate these 2's. Minus 2 cosine A minus B equals minus 2 cosine A cosine B minus 2 sine A sine B, and we're there. Divide both sides by negative 2. Right, get rid of all those negative 2's, and what's left? Cosine A minus B equals cosine A cosine B plus sine A sine B. And that's it. That's my formula, right? That's where we're going to stop. I've got cosine A minus B by itself. It equals that expression on the right-hand side. Okay, so I cleaned it up here. My handwriting is pretty decent, but that's the cleaned up version. All right. So now what? Obviously, I want to do some problems where we use this to do things, right, and see what you can do with it. But first, I want to do the others. I want to do, how about the sine of the difference of two angles? How about the sine and cosine of the sum of two angles instead of the difference? Okay. Before you start, tensing up, because I know that one was kind of intricate. They're much simpler, right? To derive all of those other formulas for the sine and cosine and the tangent as well. It's going to be much simpler because all I'm going to do is I'm going to play off of this formula that I already have, right? And that's what we're going to do in the next lecture.